All right, welcome back to another episode of the Always Adaptive podcast. This is episode 12. I have a special guest for you today. His name is Nicolas Verhoeven. He is the host of the YouTube channel called Physionic. Nick, how are you doing today?
I am excellent. Humbled to be here.
Awesome, man. I'm glad to hear it. Nick is a PhD in molecular medicine. He's been doing research for about 10 years. He also holds a bachelor's degree in psychology and a master's degree in kinesiology with a focus on exercise physiology from East Carolina University, where he also is a professor of physiology. I forget the school you just mentioned.
I was a professor at Stevenson University.
That's right. Physionic commented on one of my YouTube videos, and I checked out his channel, and I was just like, whoa, this guy is awesome. He does a lot of study breakdowns on various supplements that you've all heard of, probably some supplements that you take. And so I've also been doing some deep dives into some supplements recently. And so I thought it'd be a good idea to have him on and sort of do like a supplement myth busting episode, or just in general talking about what the evidence says about certain supplements, given that he has a tremendous degree of knowledge on the topic. So I'm hoping that you get a lot of value from this. And yeah, are you ready to dive in, Nick?
Absolutely. Anytime I can talk science, I'm in.
Yeah. So firstly, let's talk about your path a little bit, to how you got to where you are and, like your YouTube journey. Where did you start? Like molecular medicine, that's a very specific niche. What kind of took you in that direction?
Yeah. So like you mentioned at the beginning, I got my BA in psychology, and during that time I started weightlifting. So I was 6'6", 170. I was very skinny and very tall. And so during college, I decided to start weightlifting and putting on some weight. And I got really addicted to it, just like a lot of people do once they start seeing results. And I started just getting extremely interested in understanding why the body changes the way that it does, accretion of muscle and loss of body fat and all that good stuff, and just getting into the science. So eventually I graduated with a psychology degree, and I found myself just constantly researching physiology instead of psychology. I really didn't have that much interest in psychology in a relative sense. So what I did is, it would have been better timing for me not to graduate with my psych degree and actually switch majors. But ultimately, I ended up going back to school for exercise physiology and nutrition science. But because I didn't have a science background with a psychology degree, or not hard science, biology, chemistry, physics, all that stuff. So I did take a year and a half of undergrad courses, which is where I took all those courses plus some nutrition science courses, and then eventually led me to get into a master's program at the same school, so ECU, and then did that for 2 years and did research during that time as well as during undergrad when I'd gone back. And then I also, at this point, I was 6'6", and I weighed around 240, and I'd gained a lot of muscle, certainly some fat as well, but still I'd gotten much, much bigger. So my frame had really filled out. And the funny thing is, I'd also gotten my ACSM certification. I know that you have your ACE certification, if I remember correctly. So I had thought about doing some personal training during that time, and I did that, and I enjoyed it, but I wanted to really push myself into research specifically. So that's where I ended up. The idea was already kind of ruminating in my head, but I eventually pushed myself into a PhD because I wanted to learn more than just exercise specifically. So I started looking at overall physiology, and molecular medicine is a fantastic overall degree because the coursework teaches you from the chemistry standpoint, biochemistry to cell biology, molecular biology, and then it goes all the way up to physiology. So you get this huge spectrum of information that ultimately makes you really well-rounded to discuss a lot of different aspects of health. So that was the motivation for me to get a PhD in molecular medicine, because the subspecialty, if you want to call it that, is cell physiology.
Yeah, no, I got it. Did the thought ever cross your mind to go the medical doctor route, or were you just pretty dead set on that?
Yeah. I thought about it long and hard, but the issue with that is because, again, at that point I had recognized that, and you may feel this yourself, that I just became so obsessed with learning. I wanted to learn at the fastest rate that I possibly could. And it became such an obsession for me that I knew that if I was working with patients, my mind would just be somewhere else. I don't, it's not that I can't speak with people and try to help people, but I just don't think I think there are a lot of people that are much, much better than I am at that. And I'd like to focus my attention at just pulling together and just learning as much, just creating a network of knowledge inside my head that I can pull from. And that's where a PhD really is extremely useful.
Yeah, no, I like that. And I definitely am starting to feel that. I definitely love helping people, but they are in a lot of ways two different things. You could have all the knowledge in the world, but a lot of clients just don't care about that stuff. They want to tell you about their day sometimes. They're not interested in the ins and outs of different molecules and like the best splits for, this is that and the third. So yeah, that totally makes sense. On the research front, so before we get into these compounds, I just want to ask you a couple questions about studies. So obviously you're well versed in study design and all that stuff. Could you throw out like a couple tips for people that aren't really, when someone cites a study, they click on it and they're just like, whoa, what am I looking at? Like, could you just throw out 3 really simple things to look out for that'll help people? They look at a study like, okay, I'm gonna look for this, this, and this.
Yeah. So I guess the first thing would be to understand if the study that you're looking at is what's called an intervention trial. So a lot of people, I've heard the term randomized control trial. Those are intervention style trials or studies. So that would be the first thing. And the way that you can recognize that is by just ask yourself, was one of the groups given something by the researchers? So was there an intervention? Was there an application of something? If that's an exercise intervention, could be a drug, could be a supplement. If one of the groups received something, then that is highly likely to be an intervention style study, which offers a lot more information on cause and effect. So then you can actually determine, oh, this actually causes something. That said, there are limitations to that. I'm not going to go down that rabbit hole, but it's at least for the easiest way to, okay, for somebody who's never encountered this stuff, that is a better way to go about things than trying to wade through all, mechanistic research and correlation research and all that stuff, which all have their place, of course, but just looking at intervention trials. I would say, okay, so another thing that I would say for people to look at is how, if you're looking at it for personal reasons, because you want to learn something about yourself, you want to know if, let's say, omega-3s, which I know we're going to discuss later, omega-3s affect some aspect of your health. Look at the population studied. So step 1 would be, is it an intervention trial? The next step after that would be to look at, are these people somewhat similar to me? And you can easily find that there's going to be a table at, near the beginning of the study where the researchers kind of detail, like the people's weight, their ethnicity, their educational background, their cholesterol levels, all these different aspects are going to be presented. And if you are, for example, 22 years old and you're looking at a study in 65-year-olds, I'm not saying that there isn't any applicability. There could be, but it'd probably be best to try to find a study that does the exact same thing, which there are many studies that reproduce across different populations, but just look for some study that's focused more on 20-year-olds so that you can get a better indication of how that supplement or whatever that intervention is going to affect you. So those are 2 things, but it gets so much more complex going from there. As you know, I know from one of your videos that I looked at, you were looking at like effect sizes, you were looking at confidence intervals and stuff like that. And it's just, that takes a certain level of like base knowledge to go, step 1, step 2, step 3, and then you start branching out into all these different complexities, which unfortunately or fortunately require a lot more kind of background education, which is definitely doable for anyone. It's just, it takes a little bit more time.
Yeah, no, I like that a lot. And that's actually something I never actually thought about that, because like I'm a 37-year-old male, I need to be careful about how I'm digesting studies as well, because as you say, like, especially some of the studies we're going to talk about, they're in postmenopausal women like that. that has nothing to do with me. So no, I like that a lot. Today's day and age, whenever someone makes a claim about a specific supplement or a specific exercise protocol, you will see people say, oh, well, the study design was poor, or, just bad study design. I'm just going to discount that study because it's terrible. What do you look for when you look at a study? You're like, okay, this is a good study. Like, I really like the design of it. Are there like any things that really pique your interest a lot?
Yeah, there's a ton of stuff that make a study a strong study, but even strong studies have limitations, as you well know. But some of the things that I look at are, is there a control group, for example, if it is an intervention style study? So you want to know that just because you're applying an intervention, sometimes that alone can lead to an effect that may be independent of the actual substance that the people consumed or that they were exposed to, which is called the placebo effect. And typically, researchers will add a second condition to compare against that, where these people get a masked substance that doesn't have the active ingredient from the treatment group, the intervention group. And that way they can then distinguish what's placebo and what's actual real treatment effect. That would be one of the main things. And then you can even use the term randomized control trial. So control meaning that they've tried to control for as many variables as possible. Placebo would be one of those. Randomized is another thing that I look for. So does each participant get an equal chance to be in either group, if that's the intervention group or if that's the control group or placebo group? That's another thing. And then you can get into a lot of other stuff like statistics, looking at like the power analysis. I mean, you're looking at the p-values, looking at the ANCOVAs and ANOVAs and t-tests and all that stuff. And, that stuff does matter a lot because it really changes how we think about our interpretation, especially, going back to the confidence intervals that you had brought up in one of your videos. If, just as a quick example, if you have really wide confidence intervals, so the certainty of the evidence that you're looking at, for in layman's terms, the certainty is very low, then you're going to have very wide confidence intervals. And as you put more data into that data set, the confidence intervals shrink because you're getting more and more certain about that data set, that question that you're trying to answer. So, picking up on that, like if you look at a study and the confidence intervals are absolutely massive, well, the next question you should ask yourself is, well, okay, how many studies did they include? How many participants did they include? And if you see that it's only, 5 participants, or you see that it's 20,000 participants, then there's the way you interpret that is very different. And those are kind of the nuances that come from being able to just repeatedly expose yourself to studies.
No, that's great. I got one more question about that. I'm sorry about this because I never really have access to someone such as yourself, so I'm just trying to take advantage of it. So randomized control trials, I'm in the same boat as you. I like that. As soon as I see those words, I'm like, okay, let's look at this. How do you feel about meta-analysis? And I'm not going to say I devalue them, but I wait to form an opinion until I actually look at the randomized control trials that it's referencing. So like, how do you view meta-analysis? Because I know some people don't like them, but like, do you know Dr. Vinay Prasad on YouTube?
No.
Okay. So he does like cancer research and all that stuff. But anyways, he talks about this, how he would much rather have just the randomized control trial, the gold standard, as opposed to a meta-analysis, a study of studies. So how do you feel about that? Are you fully able to just give me the meta-analysis and I'm good? Or would you rather have a few individual randomized control trials?
Well, that's a good question. So a proper meta-analysis, the way that it's done by gold standard method, which would be the Cochrane review, puts in a ton of different criteria that researchers have to follow to make sure that the meta-analysis is of the highest quality. So it is true that certain meta-analyses are absolute crap simply because the data that's been input or the data that's been aggregated to put into the meta-analysis is biased or didn't search enough terms to find the studies, or maybe intervention studies, but none of them are randomized control trials specifically. There's a bunch of different factors that can taint a meta-analysis to be really bad. So no, not all meta-analyses from a really well done randomized control trial. But if you do have a high quality meta-analysis, or even relatively high quality, where the researchers do like subgroup analyses and sensitivity analyses and like a bunch of technical terms that we don't need to get into unless you're interested, then those meta-analyses absolutely trump any single randomized control trial. I don't care how good it is, simply because you're inputting so much high quality data that you can start asking sub-questions that give you so much greater granularity on the different populations that this applies to, the effect sizes, the dosages. You can do meta-regressions. Like there's so much more statistical power there that you could never do in a randomized controlled trial. So I could see it both ways, but in general, assuming that everything else is equal and everything is like good quality, I would say a meta-analysis is by far much more powerful.
Okay. Yeah, I like that. It's a good nuanced take. I've been trying to adopt that view because as you say, there are good ones and bad ones. And so there's just a lot of data to go through, which, hey, if I'm going to be in this space, I need to look at it. But like some of those meta-analyses are massive and there's just like, it's overwhelming. You get bogged down, and it's like you get bogged down on one study and then you go back to it and you still have like 30 more to go. It's like, oh boy. Okay. So let's talk about creatine. We'll get into the supplements. Finally, everyone's like, thank God. So creatine, for those that aren't familiar, creatine phosphate, you're familiar with ATP, adenosine triphosphate. So your phosphocreatine system, creatine lends its phosphate group to adenosine diphosphate, creating adenosine triphosphate. So you have more ATP. So everyone knows about creatine improving muscle mass and strength. Tons of evidence out there, but recently, I guess semi-recently, more people have been talking about bone density and more people have been talking about using it as a nootropic. So better cognition, focus, memory, and all that jazz. So I was doing some research and I wasn't able to do like a super deep dive, but I wasn't really able to find anything that showed that it increased bone density. I found one that was talking about reduced bone buckling, but it didn't improve bone mineral density. And the only one that I was able to find that did improve bone density was in rodents. So, and then the other ones, admittedly, they were giving really low doses. So like 3 grams a day to postmenopausal women in one study. And then another one was 1 gram a day, or no, 0.1 gram of kilogram per kilogram a day. So that's like a very small amount. And we all know that at least 5 grams a day is like bare minimum. I take 10. How much do you take? Do you take creatine?
Yeah, I do. I take 5 grams currently.
Yeah. So that's pretty standard for most people. So yeah, I'm curious, man, do you know of any current research that backs up the claim that creatine does improve bone mineral density or bone buckling or anything of that nature?
Yeah, so this is where meta-analysis would be really useful because, and this is what I have looked at, there is a meta-analysis, a pretty good one, that's looked at creatine and the effect on bone mineral density. Again, if you were to look at a single study, like pick out any single study, some of them show an effect, some of them don't show an effect, and there's a wide range of reasons why that's the case, why there's so-called heterogeneity, which is something that's addressed in meta-analyses.
Can you explain that for people that don't know what that is?
Yeah, heterogeneity is just basically an inherent differences in the effect that you see from one study to another study. So one study might see a 1 unit difference, the effect is 1, but another study shows an effect of 0.1. Another study shows an effect of -3. So there's reasons why there's so many differences. And there's certain like statistical assumptions that we don't need to get into, but the point being that heterogeneity is just the difference between these different effects, indicating that, okay, there's something going on here that we probably need to investigate further. And with creatine on bone mineral density, the studies that have been compiled together have indicated that there's no effect. However, to be clear, the amount of data, kind of going back to what I was saying earlier, the amount of data that was input into these meta-analyses was pretty low. The quality was pretty decent, but the amount of studies that are available are pretty low, especially when you're looking at a metric like bone mineral density, which is not something that turns over very quickly. It happens over many months, as opposed to something like water weight or looking at immune markers or looking at, any one of these different things that changes, day to day or week to week. Bone density is not just one of those. So making sure that you need mass amounts of data, especially if you're looking at a single supplement and expecting that single supplement to have an effect in a short period of time, it's kind of unrealistic to think that you would detect an effect if you just have a small number of studies. In that situation, it's probably best to look at the individual studies and determine which studies are better than other studies, and then maybe base kind of a preliminary decision off of those studies. As it stands, though, we just don't have enough data, and that's where I would actually conclude. I would not say that creatine has no effect. I just think that we don't have enough data to detect an effect yet, if there is one.
Okay, so when people ask you that, that's usually your answer is like, so I wonder because I've heard this on multiple occasions. Have you heard people talking about bone density, the bone density claim with creatine?
Bone density, not as much as muscle and the nootropic effect that you mentioned. Definitely those two. I mean, the muscle, absolutely. I'm sure you are well aware that's been like decades that we've known about that. So it's been a long time. But bone mineral density, I was actually surprised by how interested people were after the fact. I just didn't realize that going into it when I looked into it.
Yeah. Well, hopefully they keep looking at it. So I guess we could talk about the muscle mass part of it. So here's a question that you might have an answer to. You're familiar with Dr. Mike Israetel. So semi-recently, he was on a podcast and he was talking about like the loading phase for creatine. So for those that aren't familiar, there's a saturation phase with creatine. When you take creatine, it's said to take 20 grams a day for 7 days to get the muscle saturated. And then after that, you drop down to 5 grams per day. But Mike Israetel was just recently talking about how that's not necessary. You don't need to go through the saturation period. So when you talk to people about creatine, do you recommend a saturation period, or do you just say you're going to be taking it long-term anyway? Might as well just do the 5 grams and stick to the 5 grams?
I think it's personal preference. I think Dr. Israel is absolutely right that you don't need it. But if you are one of those people that wants to see the benefits much sooner, or I should say, let's say a few weeks sooner than someone else, then yeah, going through a loading phase is probably advisable to go up to like 10, 20 grams a day for 7 days and then cut down to the 5 grams. But if you don't really care and, you're going to end up, you're just kind of taking it casually, then, just take the 5 grams. Eventually your musculature will get saturated either way.
Yeah. On the nootropic front, how strong is the evidence on that? And are there any like randomized control trials that you could point me to learn more about that?
Yeah, there's a lot. There's a meta-analysis that released maybe 2 years ago or a year ago, something along those lines, where they were looking at memory and a few other cognitive metrics in relation to creatine supplementation. And that meta-analysis, interestingly enough, they got called out for statistical mistakes that they made. But as good researchers do, they ended up addressing that, reanalyzing the analysis, and then came forward with their new data, which actually didn't change the conclusion that much. It basically stuck to the same conclusion. So in that meta-analysis, which included many randomized control trials, I'd be happy to send you a few of them if you want.
Please, yeah.
And you can look at the details of those randomized control trials as well. But if we look at the meta-analysis, the effect was present. You would not detect an effect by the meta-analysis. You would not detect an effect for people under the age of 65. However, you would detect an effect if you looked at people over the age of 65. So there was an age-determined effect, as in creatine has greater benefit for people who are over the age of 65. That said, if you do open some of those randomized control trials and you look at the ones that are for younger individuals, there is still a neurological benefit that's pretty consistent across multiple studies indicating that creatine is effective. I think the only reason why it didn't show an effect is because the effect is more mild than compared to older individuals. And that's where you start getting into some of these intricacies of the effect size, so the magnitude of the effect. And if the magnitude of the effect is much greater across even fewer studies, then you can detect an effect. Meanwhile, if you have a smaller magnitude of the effect, then you need to have more studies to actually be able to detect that statistically. So that's for the younger individuals. I think that's the reason why we didn't detect an effect in the meta-analysis, but we do see an effect in older individuals. So the answer is, so to simplify, the answer is it's beneficial for both younger and older individuals. There's an added benefit for people who are older.
Okay. Interesting. Yeah, I'm excited to read that. So on the creatine point, a lot of molecules, your body goes through homeostasis, and so it's important to take breaks from it. Do you ever take breaks from creatine? Do you recommend people take breaks? Do you think your body gets accustomed to it? Or is there evidence that it's just pretty flatline throughout?
Yeah, that's true. A lot of people are concerned with like, should I cycle with different ingredients, different substances? I think there's some evidence for some substances that might be the case, but not for creatine. Creatine, you see a drop in your endogenous, so your liver and your kidneys produce creatine, and that rate of production drops significantly. I will say that once you stop taking creatine, the rate just ramps back up to where it was before. So there's no permanent effect of any sort. It's just that you said the perfect word, homeostatic mechanisms of your body's constantly trying to regulate how much of one thing that it has inside of it, floating around the system. So if you are exogenously, you are supplementing with creatine, you're massively increasing your body's stores of creatine, and therefore your body just stops producing nearly as much because it doesn't need to. There's this feedback mechanism. In terms of what I do, I've been taking creatine for almost 20 years consistently without stopping. So I haven't dropped dead yet, but I think and there's no evidence that, stopping or cycling is any, any better than just taking it consistently.
Yeah, the reason why I asked is I bumped my dose up recently. So I've been taking it for about 10 years, usually about 5 to 7 grams, but I bumped it up to 10 after I saw, more plates, more dates, Derek talking about on the Rogan podcast, talking about people aren't taking enough. And so I actually have noticed that there is a distinct feeling when my muscles are saturated where it's almost like it almost affects my brain too, where I feel more stimulated in a lot of ways. And then obviously the strength you feel in the gym, the explosivity that you feel. And I've noticed an uptick since bumping up my dose. And so I'm like, where that question came from is like, I was curious, when I was taking less, did my body get used to it? And so it wasn't having that much of an effect. So very much like any drug, you have to keep taking more and more and more and more to get the same effects. Have you ever experienced anything like that?
So you definitely don't have to take more. Creatine goes through a spontaneous breakdown. So it gets broken down into creatinine. And that's where a lot of people get overexcited about thinking that their kidney health is suddenly taking a massive hit when they take creatine, because this spontaneous degradation of creatine to creatinine then gets excreted by the kidneys. And a lot of the calculations on kidney health are based off of this creatinine level. So if creatinine increases, then kidney health, quote unquote, kidney health decreases. That's not actually the case. And even well-published, well-known institutions like the Kidney Foundation and the Kidney Institute at the NIH, so National Institute of Health, indicate that if you're taking creatine, you're probably not experiencing any sort of kidney issues. It's just that you have this increase in creatinine, which reflects across multiple blood work. So anyway, so to go back to the question, what that means is that if you are consuming more and more, there's a point where you're just consuming more and it's just being degraded. So you're basically just releasing it back again. So you're not actually taking advantage of the heightened amounts. There's some debate on the brain where you might want to take more, but again, the meta-analyses have looked at that. I think that we need more data to really be clear on if 5 grams is enough or 20 grams is enough, because some studies use 20 grams.
Oh, wow.
And so there is some argument to be made that maybe to saturate the brain, but for the musculature, for sure, around 5 grams would be sufficient across the board. And if you continue to increase it upwards, I mean, maybe for some people that are like really muscular, they may want to increase a little bit more, but once you get to a certain threshold, which is going to be probably in that 5 to 7 gram range, you're just going to be increasing your creatinine levels even more and more and more, just because your body's just going to be expelling it.
Okay, interesting. So there could even be maybe a potentially negative effect from going that high. Fish oil. So omega-3 and omega-6 fatty acids, just a quick breakdown for people. So omega-3 fatty acids, it said, are sort of like the anti-inflammatory oil or fatty acids, and omega-6 would be like the pro-inflammatory. And they say you need a good ratio of about 4 to 1, 4 parts omega-6 to 1 part omega-3. And the idea there is, the double bond is at the 3rd position for omega-3 and it's at the 6th position for omega-6. So like if you could imagine a chain of carbons, every 3rd bond is sort of a kink or a bend, whereas every 6 would be a kink or a bend. If there's more distance between the 6, then that's not going to be as flexible. So the idea is like if you have something like red blood cells, if they have more omega-3, which means more kinks and bends, they're able to go through tighter junctions without sustaining damage because they're more flexible. Whereas like omega-6 it would sustain damage during events like that. I've been kind of torn on omega-3, and it's interesting because I noticed some of your videos talking about AFib, and I wasn't aware of that, but I had a personal experience. I've had 2 personal experiences. So I did find some research. So I did find some research on gastrointestinal symptoms. And then I also found some research on cardiovascular disease risk and all that stuff. But yeah, so everyone talks really, like they praise omega-3 fatty acids, especially like the longevity sort of space. Dr. Rhonda Patrick, I think she went crazy in the beginning there. She was like the big proponent of them. And I thought, okay, let's just take it. Everyone seems to be, again, you start to trust people more and more. And then it's like, you don't really look at it for yourself. And then I actually started experiencing AFib, and I was getting these like flutters in my heart. It was like distinct. It was like almost overnight that it started happening. And then also I had to stop it because I was having some serious, I have colitis. I was having some really serious digestive issues too. And it's like, I stopped it and both of them just went away overnight. And so that like built up my curiosity on the topic, because everyone you talk to, they're like, oh, I take fish oil. It's like, you can pretty much just assume if someone takes supplements, they take fish oil. So what are your thoughts on fish oil? And let's just start there. What are your thoughts on fish oil, good or bad?
Yeah, so I'm pretty bullish on fish oil, but I have covered studies, to your point exactly, about AFib, so atrial fibrillation, which is this heart rhythm that's kind of abnormal, just in very basic terms. So there's some evidence that points to certain doses, higher doses of omega-3s, increasing the risk of atrial fibrillation. And that comes from correlation studies and actually also from some randomized control trials. However, what's really fascinating, I still don't fully understand this, is that the positive effects of omega-3s, which seem to pretty strongly point towards cardioprotective effects, as in heart healthy, as well as brain healthy effects. And the effect from AFib, even though there's a slightly increased risk, again, this is kind of early data, but let's assume that this continues to bear out in the literature, that there's a slightly increased risk of omega-3s causing AFib. The end effect of cardioprotectiveness, stroke risk, and whatnot is not increased. And cardioprotection is actually improved even with that AFib situation. Stroke, interestingly, which is one of the most affected aspects of AFib. So if you experience AFib, there's a greater risk that a person will experience a stroke. And that's because of the physiology of what happens within the heart. But omega-3 effect on stroke is null. So basically there's no effect. It's not positive or negative, which is kind of surprising, because if we see increases in AFib, we would expect to potentially start picking up some effects in stroke. And it's possible we just don't have enough data on that yet. But so far, all the studies, and there have been a lot of studies on omega-3s on cardioprotection, including a good amount on stroke, have indicated either neutral or positive effects of omega-3 consumption. And then, like I said, there's been some pretty good data looking at the brain effects. So looking at cognition, executive function, looking at memory, things of that nature. And it has a small positive effect on cognition as well. So it's really, if you're suffering from it, like you were mentioning with like colitis and whatnot, or that AFib is pretty scary. It's not,
it is, yeah.
not a fun feeling to experience. Then, yeah. It's not like a necessary supplement. It's not like you have to have it. Although, like Dr. Rhonda Patrick would probably argue that you should probably still try to get a little bit, because it's linked to longevity and all these other aspects. I just don't take it super seriously. I think you can live a perfectly long, healthy life without omega-3s, but would it add an additional benefit? Yeah, probably.
Yeah, I'm curious too. Like, the thing you got to take into account is how much omega-3 are you actually getting in your diet? Like I eat a lot of salmon, like really big. Like I just bought 3 pounds of salmon. That's 4 servings for me, so I eat a lot. And so maybe for someone like me, there is a negative effect because I'm already getting it elsewhere. I eat a lot of eggs and stuff too. So people don't think about that. But Have you ever seen this study? It's entitled, it's a randomized placebo-controlled trial of 13,000 patients. It's called Effective High-Dose Omega-3 Fatty Acids versus Corn Oil on Major Adverse Cardiovascular Events.
Maybe, but I've gone through so many
I
omega-3
know,
studies,
right?
I can't even remember anymore.
This might jog your memory. It was a study that they had to stop. They stopped early due to lack of benefit, but they essentially set it to stop at 1,600 cardiovascular events, and they had already gotten up to like 1,300. And so they did an analysis to see, okay, well, we're already pretty close to the 1,600. Is there any benefit already? And there wasn't. Have you heard any, is this ringing a bell at all?
No, not against corn oil. I've looked at other placebo comparisons or low dose omega-3s or other comparisons, but I don't remember corn oil.
Yeah. I don't like that they used corn oil as a placebo, but yeah, it was just interesting that they stopped it. Now, I mean, you could probably argue that what's the point in continuing if there was no benefit? It's not that there were a lot of events that's the reason they stopped it. It's just, hey, there's no benefit. Why are we even still doing this sort of thing? But it's just interesting. Yeah, I'm really interested to read some of the stuff that you have. Obviously, I don't have the breadth of a library of studies under my belt that you do. So it's something I'm interested in because people do ask me about it. And obviously I don't tell them what supplements to take because that's outside of my scope. But if I can at least like convey information on it, then that's good. And then also there's the ratio of EPA to DHA. So how, I guess on that front, how much do you take if you do take it, and what are your sort of ratios that you're aiming for?
Yeah, I do take omega-3s at a pretty low dose, but also when it comes to EPA and DHA, it's a little bit difficult because it depends on the metric that you're aiming for. Cardiology benefits, so looking at cardioprotective effects, tend to focus a lot more on EPA than DHA. Not to say DHA has no positive effects, but it seems to be not as robust as EPA, at least based off of mechanistic studies and some clinical trials as well. Then when you're looking at brain health, suddenly it flips completely. So it becomes strongly DHA focused and a lot less on EPA. So it really just depends on what you would prefer. And an easy way to, I guess, get kind of both is try to aim for a 50-50 split, which is probably not going to be the most ideal for either one, but it at least offers some protection both ways. So that's usually roughly what I aim for.
I gotcha. Okay. All right. Collagen. Do you take collagen? What do you think of collagen?
Yeah, I do. Collagen, okay, so unlike creatine, which, as you well know, has tons of research behind it, especially from the muscle front, omega-3s have a good amount of research behind them or around them. Collagen peptides have some research behind them, and it just depends on which outcomes you're looking at. However, most of the studies, well, actually not most, all the studies have failed to do certain key comparisons that give us some real granularity on if people should be supplementing with collagen or not. And what I mean by that is one of the common questions that people ask is, well, should I take collagen peptides or should I take just up my protein intake? And there's mechanistic reasons for saying that you should take collagen peptides, but we don't actually have any clinical evidence because there's no comparison. There haven't been any studies, as far as I'm aware, up to this point. I'm really hoping that happens in the near future, that actually compare protein versus collagen peptides on not just one or two metrics. Like, I should correct myself. I think there's been one study that's looked at muscle, but I don't think anyone in the exercise or muscle physiology world would say that collagen peptides are supposed to overcome, like a whey protein or a casein protein or a high quality protein like that. So ultimately, they determined that the whey protein and the casein protein were better than collagen peptides, which isn't exactly a shock. But when you're looking at joint health, you're looking at skin health, you're looking at bone health, those are the metrics where collagen peptides may have an outsized benefit. We just don't have those clinical studies yet. But again, mechanistically, you could easily make an argument that collagen peptides have a unique benefit that protein don't offer.
Yeah. No, you just made a really good point there. And I know in our world, most people do know that collagen is pretty worthless as like a muscle compared to whey or anything like that. But I do get asked this a lot, so I do want to clarify this. collagen is low specifically in leucine. And so the amount of leucine that you're getting is 0.2 to 0.6 grams per 10 to 20 gram serving of collagen. And so the amount you need of leucine is about 2.5 to 3 grams per meal. And so you're just way better off getting it from whey or eating meat in the first place. So it's just not, as he just said, it's not a good supplement for that, for those that are thinking in their head, hair, skin, nails, and muscle, not so much the muscle front. But on that point, so things to compare it to. So one of the major medications that they give people with colitis is called mesalamine. And so I just started taking collagen 3 months ago or so. And it's because I came across this study, because the doctors, my experience has been really negative in the medical industry. People have given me very little lifestyle interventions or, talking about anything else other than medication. And I've had colitis since I was a teenager. And so it's really upsetting that I even have to do this, but unfortunately, I just have to do my own research and experiment on myself. And so I came across a study where they were comparing collagen and collagen peptides to mesalamine, and both of them performed much better than mesalamine. And in fact, mesalamine didn't even perform as well as the control group. It actually performed worse. And so, but this on rodents. So actually that's a good segue. How do you feel about rodent studies? Now, obviously I'm taking this with a grain of salt and I'm doing my own experiment. And everyone, this is not medical. Like if you have colitis, do not do this, talk to your doctor, all that stuff. But how do you feel about rodent studies when they are like placebo controlled randomized trials? Do you just throw them out or do you find them useful at all?
Well, you typically don't get randomization when it comes to rodents. But so rodent studies, I love them. I would never make a clinical argument based off of rodent studies, but rodent studies are invaluable in that they offer so much information. They're kind of this bridge between cell work, so in vitro studies, and human studies, in that rodent studies allow us to get a lot more information on mechanisms that we can also get from cell studies, but we can translate that to a mammalian model. So we can actually look at an in vivo or living organism. But on the other hand, what it can also offer is it can bridge this gap for certain invasive measurements that we can't do in humans. So if you wanted to measure, like a big buzzword for a lot of people is autophagy. If you want to measure autophagy in the liver or the kidneys or whatever, you can't really do that in humans. You can't just take pieces of people's kidneys or whatever.
Right. I hope not.
Yeah, I hope not either. There are very specific circumstances where you could, but it's that's like after they've passed away or, stuff like that, like not when they're living. So, or, from surgery, you can, if they're having a kidney removed, you can also take a tissue with their permission, all that stuff. Anyway, it's beside the point. So rodent studies give us information on that. The opposite end of rodent studies that people, I think, have started to really realize, I think a little too cynically in a way, that they've started looking at rodent studies. Initially, it was like, well, there's a study. And then people would open it up and it'd be a rodent study and they'd be using 5 kilograms of, collagen peptides. And then they'd be like, well, see, collagen peptides work. And it's just nonsensical because for many different reasons. One, because rodents aren't humans, but also beyond that, the doses that they're sometimes offered, especially when you're looking at toxicology stuff where they're looking at, 1,000x exposure that humans would never in their lifetime ever experience. That kind of gets translated by people that don't know how to read studies into, oh, now, we should avoid this substance or whatever it might be. And it's just an improper use of rodent studies, but there are immense benefits from rodent studies that I think are underappreciated. I think, the cynicism that a lot of people now experience to the point where they see a rodent study and they're like, oh, I'm just going to dismiss this. Well, why are we even discussing this? And that I think is it's missing the, what is it? I don't even know if that applies force for the trees. The point is that they focus too much on now just dismissing rodent studies, and they don't have this nuanced view of this is the strength of a rodent study, and this is the limitation of a rodent study, and it fits into the hierarchy of evidence that we need to look.
Yeah, I agree. I think that's spot on. I think they have their use, and there has been sort of way too many people dismissing them. But so back to the collagen point. So how much do you take? Is there a specific brand name that you take? And what are you taking it for?
So I take 10 grams collagen peptides. I use it from Vital Proteins, but just to be clear, I have no connection with them. I don't care about them. I may switch, tomorrow. I don't know. But it's just, they just also combine it with hyaluronic acid. So I just use them. You can also use bulk supplements. That's another great brand. It's cheaper, but it's only collagen peptides. That's also been vetted. So yeah, I use 10 grams and I use it primarily actually for my skin. So I'm trying to retain my youth as much as possible, trying to grasp to my youth. So I've been taking it for about 7 years now. And I've been doing a lot of things, not a lot of things, but I've been doing just some really basic things just to make sure that I continue to maintain my overall health, but also my looks to the best of my ability.
Yeah. No, I've definitely noticed some improvements in my skin, 100%. Like little, you wake up, you have like little crusties or something, your skin just kind of dried out. It doesn't really exist anymore. It's really interesting. I didn't finish my point on that mesalamine versus collagen study though. So I found that study and the mesalamine group did worse than the control group. The collagen group did really well, a lot better than the control group. And then the peptides group did even better, which is expected because peptides are more easily absorbable. But so I switched. I stopped taking my mesalamine. I replaced it with collagen. And I've noticed a marked improvement. And it's just like little things. Yes, like overnight. And that's a really expensive medication, about $500 for a 30-day dose.
Wow.
So
that's awesome.
Yeah.
That's really cool.
Yeah. So I was really excited for that. So I think, if you find rodent studies and the dose that they're giving the rodent actually makes sense to your point of like, slamming them with 5 kilograms of collagen or whatever. But it's interesting, man. I think I'm really happy that more people are looking into research now because there are doctors that don't even read studies,
True.
and hey, they have really tough jobs. They're working 12 to 14-hour days and they're trying to spend what little time they can with their own families and stuff. And so people don't really have enough time, but, hopefully with channels like yours exposing stuff like this, I think it's more easily digestible for people like doctors to come in and be like, okay, well, here's this guy who's a PhD in molecular medicine and all this stuff. Like he's saying this is good stuff, but yeah, hopefully more to come. Okay. So lastly, I want to talk about NAD and NMN. So my understanding, so I actually just learned something new about this. I didn't realize NMN was banned because they were doing research on it as a new medication. And that was David Sinclair's company. I didn't know that was by his company. And so NMN, my understanding is the NAD is not small enough to cross the cell membrane. And so NMN is like a precursor. You get that in, and that's supposed to improve NAD levels. And from what I could find, yes, it does. It increases both NMN and NAD levels, but the outcomes that they were measuring weren't really different. So I guess, are you aware of any outcome studies where it improved NAD levels and the like, but also they were looking at other outcomes and you saw an improvement?
Yeah, so this is a pretty nuanced conversation. For one, the reason why NAD is not usually the supplement that people consume is because NAD is it degrades very quickly in serum. So once it enters your bloodstream, it doesn't stick around for very long. So it doesn't actually get to the tissues because it gets degraded. So that's why we've been using these precursor molecules like NR and NMN, and those are much more stable in serum. And we do show that there can be increases in NAD levels. However, so I've looked at, I forgot how many studies it was now, 12, something like that, clinical trials on NMN and NR, but more focused on NMN. And the claims around NMN and NAD were that NAD is such a vital molecule, and it is within our cells. So it's involved in gene regulation, it's involved in mitochondrial health, it's involved in our metabolism. There's a bunch of different functions, actually hundreds of functions for NAD. So it stands to reason that since as we age, our NAD levels drop, that you'd want to boost those NAD levels, and that could actually potentially have profound effects on your cells. And they've shown that in animal studies, and they've shown that in cell studies, that if you increase NAD, there tends to be some preferential benefits, like the cells just function better, and the animals are just react better and whatnot, and just age better as a whole. So then it makes sense to then try to supplement it in humans. And across these like 12 plus studies that have released, they've used varying doses of NMN. Some of them have been very low doses, like 250 milligrams, all the way up to higher doses of 1 gram or 2 grams, which is kind of where some people believe that you start to really experience benefit. And unfortunately, most of the studies indicate just about no effect of NMN supplementation. So that means that they've measured blood values of NAD, and they see this conversion of NMN to NAD. So they see a rise, but then they don't actually measure the tissue levels. And I think that there's been only a few studies that have actually measured tissue levels and have been unable to identify a meaningful rise in NAD levels in the tissue, which is where you actually want the NAD to be found. So that's problematic in its own right. But even if we were to assume that NMN is somehow having an effect within the cells, the outcomes that they measure, so they measure like cholesterol and triglycerides and body weight and muscle mass and all that stuff, and most of the studies indicate no effect. However, the studies that do indicate an effect tend to be in older individuals, and on top of that, people that are like insulin resistant or have diabetes or have some sort of condition that kind of leads their physiology to not be working exactly the way it's supposed to. So that's why I say it's a little bit nuanced, and the overall effect of NMN and these NAD boosters is pretty small. So, and then the final thing I'll say on this is that technically these studies are not studying what they should be studying, because a lot of the animal studies are looking at longevity markers. They're looking at all these different markers of mitochondrial function and whatnot. And none of these studies, none of the clinical studies looked at those. They just looked at basic blood work like LDL levels and total cholesterol and triglycerides and whatnot. So like, is it that much of a shock that we don't see an effect? I would say no. But that said, we also can't say that there's strong evidence that NAD has these significant effects. And I will say there's one study, I believe, up to the point that I know, that did measure like DNA damage markers and did look at one metric of this DNA repair mechanism that NAD is supposed to work in, and they showed no effect of NMN. So, but that study also used one of the lower doses of NMN. So there's a lot of critiques and a lot of all over the place. And so I would just conclude by saying that we just don't have any good clinical evidence indicating that NMN up to this point is a benefit to our health, although there's a lot of room for that to change, assuming that researchers want to start pursuing some of these other outcomes.
Yeah, I mean, isn't that a crazy? It's like the body is magic. That homeostasis mechanism. It seems like some of these supplements, creatine with the bone health, it was in older people, right? So it's like there's not an effect unless you're older and losing your bone. So it's like these supplements, your body's trying to get back to normal. And then, as you say, with the NMN, it's like in older people or people that had type 2 diabetes, it's like it really only works if you're lacking the stuff in the first place. And then even then, it's just trying to get you back to where like the perfect baseline for all individuals.
Yeah. Yeah, it is pretty amazing. I mean, homeostasis as a whole is really incredible. I think one of the greatest examples of that is blood pressure and the number of different regulations that our body has to control our blood pressure. I mean, from our kidneys to our blood vessels to our heart. I mean, there's all kinds of hormones going back and forth, just trying to make sure that our blood pressure is within a certain range. And then what we do is over time, as we continue to ingest things or not do certain things or do other things that ultimately lead that homeostasis to get that set point kind of increases upwards. I think that's a really fascinating example.
Yeah. David Sinclair. So like all the things you just said, that was a perfectly reasonable, nuanced, well thought out take.
Thanks.
But when you listen to people like David Sinclair, like he's very bullish on some of these supplements. What are your thoughts on him? I know there's been some controversy surrounding him and the company that went under that was doing research on sirtuin-1 and all this other stuff. Do you have any thoughts on David Sinclair?
Yeah, I don't know what to make of him. I mean, he definitely looks bad in certain circumstances based off of like what's been happening with NMN, NAD boosters and whatnot. And then obviously what happened with GSK, I think giving him like, buying the resveratrol situation for like $700 million or whatever it was. I mean, it was some insane amount of money. Yeah. And it ended up, just falling flat on its face. I don't know if that was completely his fault or not. There was, I remember it was something related to, there's some technical issue. I'll just put it that way. So I will say with the NMN studies, one of the rebuttals that I've gotten is, that from people that really like David Sinclair is that, well, he wouldn't measure these different outcomes. And I completely agree, as I mentioned before, but he has been published recently as of last year in human clinical trials looking at NAD boosters. And that same study was horrible. I mean, just really bad statistical like manipulations that were done to make sure that you would detect an effect in certain ways. And the effects were really small. And it's just, to me, and then people have been also saying, well, you also have to take NMN with something else. He always says you have to take NMN with something else. And I'm like, well, I mean, he was one of the published researchers. So why didn't he push for that something else to be added to this clinical trial? And it's not there. So like, I mean, a person can say something and then when they're given the opportunity to do that thing, like you do it, don't. Right. So I'm not, I don't know him personally. I don't know really much about his personal life. I just know that some of the research that he has indicated as like strong evidence for NMN is a lot shakier and a lot weaker than we initially thought. But again, I just want to be clear that it's entirely possible that in 5 years, we'll have a lot more studies that actually look at the measures that we're supposed to, and we'll see some real benefit of NMN supplementation because the idea does make sense.
Yeah, no doubt. You mentioned autophagy a bit ago, and that's how you and I met. I was breaking down a study about that autophagy study from Lane Norton. Well, I guess he first talked about it, but you had commented about how it wasn't really a study looking at autophagy, and I agree. It was looking at calorie restriction and all that stuff and weight loss. What are you aware of any good human randomized control trials that are looking specifically at intermittent fasting and autophagy? Or, I mean, even rodent studies, like, is there anything, and what markers do you like when you're like, okay, this is a good autophagy study?
Yeah, so as far as I'm aware, there are no fasting studies looking at autophagy markers other than the one that Dr. Lane Norton mentioned in that video and that you covered. So I've done a lot of like hands-on autophagy research in the lab. So I'm pretty well versed on the different markers that researchers would use to measure autophagy. And it's kind of ever changing, but there are certain base markers that researchers continue to use and probably will continue to use for the rest of time. But even as we add more, there have been rodent studies that have looked at autophagy. There have been human studies as well that have looked at exercise and autophagy, or they've looked at other aspects and other interventions, if we can go back to that term, other interventions on autophagy. And they're not like the best design studies, but, even those studies are much better than the one that Dr. Norton mentioned. I don't have a problem with Dr. Norton. He puts out a lot of great material. So the markers that typically researchers would look at is something like LC3, LC3 1 and 2. They would look at ULK. That's another metric. And then upstream of that, they would look at AMPK. But AMPK can have a tremendous effect on all kinds of different systems. So the better two markers would be to look at LC3 1 and 2. That's probably the biggest one. And then ULK, what's known as phosphorylation, or the tagging of ULK. So, and the conversion of LC3, LC3-2 is an indication of autophagy is starting to happen.
Sorry to cut you off. What is LC3? Yeah. What does LC stand for?
That I have no idea.
Gotcha. Okay.
I don't know what ULK stands for either.
I don't think most people do. Everyone's so accustomed to the acronyms and stuff.
No, I'm sure some autophagy researcher that like specifically studies those knows their exact, their full name and whatnot. LC3 though, like in terms of their function, LC3, so autophagy are these vesicles that form out a organelle, a section of the cell called the endoplasmic reticulum. And so you have this endoplasmic reticulum, which is responsible for helping you with processing proteins and fats and cholesterol and all that stuff. And what it can also do is a membrane, a section of that endoplasmic reticulum can get peeled off of the the endoplasmic reticulum, and can start forming its own kind of blob structure within the cells. Now, that blob structure is a very immature form. And as it matures, it picks up these different components that are autophagy related. So the cell will start producing these different autophagy components and will start integrating them into the membrane of this blob structure that's going through the cell. And one of the major ones is LC3-1 and 2. In that LC3-1 gets processed or turned into LC3-2, which activates or is one of the greatest signals for autophagy. And that's the idea of looking for this conversion of LC3-1 to LC3-2, because you're essentially seeing that there's a maturation process of autophagy. It hasn't just started, it's actually going through its maturation process and allowing for the degradation and destruction of the different components that it's targeted. And the targeting process, there's a bunch of proteins that are involved in that, and there's a bunch of maturation proteins that are involved, and it gets pretty complex, but those two proteins are definitely among them. And then researchers would argue that autophagic flux is something to measure, and that's kind of become a more recent thing, not just looking at LC3 measurement at one time point, but looking at it at multiple time points to see what happens. Does it continue to get processed over time, or does it get stopped at a certain point? Things like that.
Okay. One last question, and
Sure.
this is the big one, and I'm sure everyone's dying to know, what supplements do you take? And like, what supplements would you declare are sort of must-haves in your stable?
I don't take a whole lot of supplements, actually. I cover a ton of supplements in my videos and in my analysis.
Isn't that funny? I don't either.
Yeah, it is funny. It's just people are so obsessed with supplements. They just want to know more about supplements. To be fair, people actually also are really interested in exercise, which I find really commendable. And nutrition as well. But nutrition is an area where people get really it's like tribal warfare. So the supplements that I take are creatine, as I mentioned before. I take collagen peptides. I take Omega-3, and when I'm not consuming enough of like food sources, I'll take lutein and zeaxanthin. So it's a really cheap eye supplement that I take as well. That's got really robust evidence in favor of it. So I think
interesting.
That's
what was the second one? Zeaxanthin?
Zeaxanthin. So xanthin. So XANTIN. Xanthin. Yeah. Zeaxanthin.
Right.
ZEAXA. And I do take whey protein as well, simply because the way my nutrition is structured, just sometimes I need that added protein. So I'll consume whey protein or casein protein or something like that, along those lines. But in terms of daily consumption, it's creatine, collagen peptides, Omega-3, and lutein and zeaxanthin. And I don't plan on adding any more to that than maybe a multivitamin every once in a while, but I'm not overly religious about that. And
Gotcha.
That doesn't mean that other supplements aren't also beneficial, but people just get into this list of supplements. I've had clients that have had 50 supplements that they're taking, and they're asking about the timing of everything. And it's just you're basically worrying about that 1% difference, which probably doesn't make a huge difference. And so in terms of the top supplement or top 2 supplements, I would say that people should consume, it's no doubt creatine. It's cheap. Creatine monohydrate, to be 100% clear, micronized creatine monohydrate. It's easier on the gut. It's got profound benefits across your body. Even it's the most studied supplement, thousands of studies on it. It's incredibly safe. The only people that might have issues with it that we know of, like people with kidney disease, like actually already have kidney disease. But beyond that, if you're healthy, if you're older, younger, whatever, creatine seems to have some really profound benefits on depression, has benefits on cognitive health, has benefits on muscle health, tendon. I mean, it's just like all over the place. So, and it's super cheap. So, and don't worry about the hydrochloride versions or the pyruvate versions, or, it's a markup that where they sell you certain things.
Or the gummies.
Gummies. Yeah. I mean, whatever, like just get the cheapest possible creatine and you'll be good to go. That would be, if you only wanted to spend one supplement, that would be it.
Right. Yeah, these gummies are getting out of control, man. They're so expensive. I don't understand how people are seeing that and they're like, yeah, that's a deal. It's like, oh my God. It's
I
like
haven't
3-4 times the price.
Really? Wow. Okay.
Oh yeah, dude. It's 1 gram. So the last one I saw, I think they're called Beast Bites or something like that. They're going crazy on TikTok, and it's 1 gram per gummy. So you have to eat 5 of them. And it's like a package of 30 or something like that. It's like $40 or something crazy.
Wow.
It's absurd. It's really terrible. But hey, man, some people are finicky about textures and, I get it, but it's like, yeah, it's just really expensive. I can't do it.
Yeah, I would. I mean, there's flavorless creatine, and
Right.
you can just put in a little bit of water. And another tip is if people do have like gastrointestinal issues, just drink it with more water. Just dilute it even more, or also drink, let's say, smaller amounts, like 3 times a day, for example. That's another way to make sure that you avoid the gastrointestinal issues that some people might experience.
Yeah, that's a good tip. Okay, man. Do you have any closing thoughts on any of the supplements that we've talked about, or just any closing thoughts on supplements in general?
Sure, I would say avoid supplements, and I mean, genuinely, like if you aren't taking care of, let's say, the big 3 of, if you're not exercising, if you're not focusing on your nutrition, and if you're not focusing on your sleep, you should not be worried about supplements. And certainly supplements will help each one of those, especially like sleep, for example. I know some people really struggle with that. But there are other non-supplement ways of improving all of them. And that 80% of the benefit to your health and your longevity and your health span and all that stuff is going to come from focusing on those 3. But after that, yeah, if you want to try different supplements, then the ones that we discussed are good ones. I'd probably save your money on NMN. You mentioned that it's banned in the United States, but people still find ways of getting their hands on it.
Yeah. No, I think that's perfect, man. Thanks for saying that, because that is a big point. I think it was Lane Norton again. He's come up a lot. It says stepping over dollars to pick up quarters or something like that, where people they're not exercising, they're not looking at the food they're eating, and they're so curious about supplements. And it's like, you could take all the supplements in the world, but if you're not checking these other boxes, like you said, it doesn't make a lick of a difference. So absolutely, man, right on. All right. Any new projects you're working on, or anything that you want to shout out? I know you have a physionic community, right?
Yeah, I do. Yeah, I've got a private community. It's free, where people just come and engage and just talk about science. I can't dedicate as much time to that, so I've got a paid community as well, where I actually release like my full investigations. That in there, I try to be as focused as I can, just because it gets overwhelming after you get to thousands of people. That all, I love the fact that people are so engaged in the science and whatnot. The investigations that are coming up, I'm looking at, let's see, actually, don't mind me. I just need to quick pull out my phone.
Yeah, no problem.
Because I have them all written down here. Oh yeah. So I'm going to be looking at, so there's a study that replaces plant-based foods for meat. And it's not actually one study. It's an analysis of a substitution analysis, where they try to figure out what kind of health benefit or worsening that happens when you substitute plant foods for meat. So you reduce your meat intake and you increase plant foods, different types of plant foods. I'm also going to be looking at curcumin for arthritis, creatine's brain mechanism. So we talked about creatine. I'm going to be investigating like exactly what happens within the cells. That's actually releasing tomorrow. Fiber on blood pressure, some work on insulin resistance, potassium on on our blood vessels, why blood pressure recommendations have been set to where they have been. There's a really influential study called the SPRINT study, the effect that exercise has on mitochondrial health, and one that you've covered is canola oil on inflammation. That's one that I've been working on actually for like 6 months, and it just takes so much time that I just haven't had the chance to really focus in on it. That's going to be a fun one.
Awesome, man. Excellent. So you have your Physionic YouTube channel. So for those of you who don't know, he's a YouTuber, pretty big channel. And as he just said, his projects that he works on, he covers studies. And so if you want to follow him, definitely subscribe to him on YouTube, Physionic. I'll put the link down in the description. And do you have any other social media links where people can find you?
No, if you just go on Google and type in Physionic, it'll pop up. I mean, it should be pretty present. But YouTube, like you said, is the biggest platform.
Gotcha. Awesome. Well, Nick, thank you so much, man. It really does mean a lot that you reached out the way you did, and you've been really gracious with your time today. And yeah, I'm looking forward to hopefully we can do this again. Maybe we can talk about exercise specifically as opposed to supplements or something. But yeah, thank you so much, man. And I'm really looking forward to those projects that you just mentioned, man, because you do a really good job. So please keep it up.
Yeah, thanks for having me on. And you keep it up too. I mean, you're doing a great job yourself. So like I said, off air, we need more people that are evidence-based and hold themselves to that standard. So it's really wonderful to see. So yeah, keep it up.
Awesome. Thank you. Well, this is the Always Adaptive podcast. If you're still here watching and listening, thank you so much. I appreciate your time. If you're interested in coaching inquiries, you can email me at randall@alwaysadaptive.com. My website is alwaysadaptive.com. And if you search Always Adaptive on social media, I should pop right up. I will see you at the next one.